Hello, we are back. We got cumulative review number 10. All right, I'm doing 8 to 15 here. Very exciting stuff. Cannot wait. This is cumulative review. I wish it was 8 because that would have rhymed, but here we go. We got number 10. All right, let's do number 8, letter A. First of all, we're talking about complex numbers. Remember our complex number clock, all right? If I have I to the 7th, I want to try to write that in terms of I to the 4th power, because I to the 4th power is 1. So that's I to the 4th to the 1st times I to the 3rd, right? I to the 4th is 1. I to the 3rd is negative I. Okay, because it's I squared times I, and I squared is negative 1. So I to the 3rd becomes negative I. So really, this is 2 negative 2i minus, well, what's the square root of 16? All right, what's the square root of, negative 16. This is negative 3. Come on, dude. There you go. Negative 3 square root of negative 3i square root of 16, right? Negative 16, the I came out. Well, this is negative 3i times 4, which makes this negative 12i, and then I have plus 2 on the end. I just did a lot of work there, all right? Remember, this I to the 7th became I to the 4th times I to the 3rd. I to the 4th is 1. I to the 3rd is negative I. Negative 3 times the square root of negative 16 became negative 3i root 16, which became negative 3i times 4. Negative 3 times 4 gave me negative 12. Combine my like terms, I get 2 minus 14i. Okay. Next one here, I got a binomial times a binomial, which means I'm going to do FOIL first, outer, inner, last. Oh, this little mouse here. Wow. That's, oh, God, bless America. Why does it have to do that to me? All right, so minus 15i squared. Okay, so now I have negative 6i and 5i, which gives me, negative I. All right, I have 2. Negative 15i squared is negative 15i squared times negative 1, right? I squared is negative 1, so really it's plus positive 15, which makes this 17 because of the 2. All right, because of 2 plus 15 gave me 17. Okay, let's keep cruising. All right, I have negative square root of 7 times negative square root of 12. Well, I know that this negative, the first thing I want to do when I see a negative number underneath my square root is pull out the I. All right, once I pull out the I, okay, I'm going to make this I root 7 times, I know this is square root of 4, square root of 3 times 2i root 3. Square root of 4 is 2. All right, now I can write this as I can multiply these two. 2i times I gives me 2. 2i squared. There it is. How about it? Root 21. How does it do this? I just don't understand. I squared is negative 1, so it's negative 2 root 21. There you go. Okay. Now, okay, what do we have here? We have a complex number in our denominator, all right, which is something we do not want. So I need to multiply the top and the bottom by the conjugate. All right, I'm going to do my this bottom work in red. All right, this work right here. Okay, before I do the top I just distribute that 3. Okay, but the bottom, I have 4 minus 2i times 4 plus 2i. And this can trip some people up sometimes. All right, that's 16. That's plus 8i. That's minus 8i. And that's minus 4. I thought that would make a difference. I squared. Remember, so now this positive 8i and this negative 8i, they cancel out. Okay? The 16 comes straight down. 4i squared is negative 1, so it's negative 4 times negative 1. So plus 4 gives my denominator to be 20. So I distributed this 3, right? So I have 12 plus, excuse me, wow, 6i, and that's all over 20. When we write a complex number, we want to write it as 2 terms. Okay, so I have a monomial on the bottom, I have a constant on the bottom, so I'm going to write this as 2 separate fractions. 12 over 20, I'm going to split it, plus 6 over 20i, or 6i over 20. Alright, so after I split it, I reduce. Then I get, what goes into both? 4 goes into both. 3 over 5 plus 2 goes into both. 3 over 10. You want to write it as 2 separate terms like this because technically standard form is a plus bi. Alright, and we want to, because of the complex number, I need to separate it from our constant. Okay, need to separate it. Alright, we want to evaluate the sum or difference formula. I'm going to write this as a sum, and I'm going to choose, remember we don't want to choose anything in the 30-degree family because of the root 3 over 3. Alright, I want to try to keep in the 45 and my 60-degree family. Okay, so right now I'm going to make this tangent of, what did I choose? 315 plus 120. So I'm choosing a sum. Okay, because those two are on my unit circle. Alright, the sum formula becomes tangent of 315 plus the tangent of 120 all over 1 minus tangent 315 times tangent of 120. Okay, well I know that the tangent of 315 is negative 1. I know the tangent of 120 is negative root 3. Easy, people. Then I got 1 minus negative 1, 120, negative root 3. So 2 negatives make it a positive. So I have, oh, buckets, of course. Oh yeah, of course, let's just put it there. I just can't even do it with the mouse either. This is so frustrating. I don't use the other one. Well, the other one is being used by, I'm not sure who. I would love to find that other one. The other one, I mean laptop. Here we go. So the 2 negatives make it a positive. Make these numbers positive. That doesn't change that sign here. Okay? That still becomes 1 minus root 3. Alright, because technically, well, let's think about this here. Literally, I have negative, negative, negative. So these 2 negatives could become positive. Alright, but that would make this still a negative root 3, which stays the same. Remember, I cannot have a radical in my denominator, so I need to multiply by the conjugate so that the radical disappears. Now, it doesn't mean the entire denominator disappears. Alright? Does not mean the entire denominator disappears. The denominator is still there. If I multiply the top, I get negative 1 minus root 3 minus root 3 minus root 9. I'll just write it as root 9 for now. We all know what that's going to be, right? Well, I hope so. If I multiply the bottom, or I attempt to draw the lines at least, okay, I get 1. And some of you may well do this part in your head, and that's totally fine. I'm going to write it out step by step for you. Plus root 3 minus root 3 minus root 9er. Okay? Well, I know that this is 3, and this becomes 3 as well, right? Alright, I know that these two, positive root 3 and negative root 3, are going to cancel. I know that 1 minus root 3 is going to give me negative 2 downstairs in my denominator. Alright, so I have negative 1 minus 3 in my numerator. Well, negative 1 minus 3 gives me negative 4. Negative root 3 plus negative root 3 gives me minus 2 root 3. And that's all over negative 2. I'm going to simplify. That becomes 2. Negative 4 divided by negative 2 is 2. Negative 2 divided by negative 2 is plus root 3. Alright. Here we go. This is a SOAP problem. This is a SOAP problem. Okay, so we're going to factor this. Alright, so I need to figure out what my a value is. My a value is going to come from right here, the 27x to the third. Well, if I think about what's the cube root... Are you kidding me? Are you kidding me? Are you kidding me? Who's kidding? Oh my goodness. Come on. Come on, come on, come on. Cube root of 27x cubed, well, the cube root of 27 is 3. Or it can attempt to be 3 if this thing, yeah, it's a slash, for sure. It's a slash. I'm sure you're just sitting there laughing. Yeah, it's really funny. Really funny. Alright, the cube root of x cubed is just x. The cube root of 64, you're probably like, you're nuts, dude, is 4. Okay? So this is the SOAP problems where it's a cubed plus b cubed. Alright, so the SOAP means that I have a 3x plus b. The s stands for same sign. This first term is a squared. We'll have to square 3 and the x. Opposite sign makes this negative. A times b, which is 12x, plus 4 times 4, or 4 squared, which gives me 16. That's always positive. Yeah, for sure. Positive. Alright. Yeah, that's alright. That's good. I don't think I'm going to get that next one in, so we're going to stop here. Okay? And then I'll pick up on 11 with the next video. Alright.